Hey everyone, and welcome back to the podcast. I'm Mark, and as usual, I'm ready to explore some interesting tech topics.
And I'm Jenny, here to make sure Mark doesn't get times carried away with the nitty-gritty. But I'll admit, today's subject is pretty captivating, even for someone like me who's not a tech guru.
Oh, it really is. We're diving into the world of times bigger asterisk GPS. And believe me, it's far more than sheer size. It's about, well, it affects almost times everything in modern AI.
Right, because we're not times discussing improved gaming graphics, though that is a perk. We're mainly tackling those enormous AI models, the language models that can craft articles or generate computer code, right?
Precisely. Consider something like GPT-3 or even more recent models. These models have billions of parameters. Think of them as the AI's brain cells, in a way.
Okay, brain cells. I find that analogy helpful. So more parameters mean a more complex AI, able to handle more advanced tasks?
Exactly. But here's the catch. Holding all those parameters and completing all the calculations needed to actually train times the AI that consumes a asterisk significant times amount of memory. And I mean significant.
So that's the reason for larger GPUs? They possess greater memory to accommodate these massive models?
You've got it. I came across the NVIDIA H100 recently. It has 80 gigabytes of HBM2E memory. That's times high bandwidth memory, designed for incredibly fast data transfer.
80 gigabytes. That seems like a lot, even compared to my high-end gaming laptop. But is it sufficient for, let's say, a gigantic language model?
Well, that's where it gets complicated. A model like GPT-3 with 175 times billion times parameters, using FP32, which is a method of representing numbers, you'd require around 700 gigabytes of memory solely times for the parameters. Essentially, just to asterisk store times the model.
Wow. So even that 80 gigabytes GPU isn't enough by itself?
No way. That's why researchers frequently utilize multiple GPUs collaborating together. Or they employ methods like times mixed precision training.
Mixed precision. Could you explain that?
Sure. Instead of relying on FP32 for everything, which requires 4 bytes per parameter, they might opt for FP16, using only 2 bytes. It's like representing the data more compactly.
Oh, similar to compressing a file. So you conserve space, but are there downsides?
There can be. You might sacrifice some precision. Think of it as the contrast between a high-resolution image and a somewhat blurred one. For certain tasks, it's acceptable. For others, you need that finer detail.
So it involves a trade-off. You're balancing memory needs with the accuracy of the results.
Precisely. And it goes beyond just memory. Larger GPUs also offer increased times. Imagine it like having extra cores in a processor. They're capable of performing more calculations at once.
So they're not solely larger storage spaces, they're also quicker at processing all that information?
Correct. These modern GPUs have tensor cores, specifically engineered for the types of calculations AI models require, like matrix multiplications. It's centered around parallel processing, executing numerous operations simultaneously.
Okay, I think I understand. But there must be a disadvantage, right? These huge GPUs probably consume a asterisk lot times of power.
They do. That's a genuine concern. The H100, for example, has a TDP, or thermal design power, of around 700 watts. That generates substantial heat.
So there's also an environmental aspect to keep in mind?
Undoubtedly. But consider this. If a bigger GPU can train a model much quicker, it might use more power times hourly, but it completes the task in fewer hours overall.
That's a valid point. It's about the complete energy usage, not only the immediate power draw. So, are there any other options besides just using a larger GPU, something more sustainable?
Well, some people are looking into CPUs, FPGAs, or even neuromorphic chips. Google's TPUs, or tensor processing units, are also an option there. They have great performance, but use less power.
That is good to hear. I know a study showed optimized algorithms can reduce memory needs by up to 75% for some AI tasks. Do you think improvements to algorithms and software could remove the need for a large GPU altogether?
That's a great question, and something that people smarter than I am are working hard to figure out. But I think that large GPUs will probably be a part of AI for the foreseeable future.
And of course, the cost. These bigger GPUs get pricey, and quickly.
Yes, they do. It is a barrier to many smaller companies, or those just starting out.
I see. So is relying on cloud services the primary alternative for smaller groups or individuals?
Cloud computing is a major factor, but open source software access can help level the playing field. It's a collective effort to ensure these capabilities aren't exclusive to major corporations.
It's a truly captivating balancing act, isn't it? We require these incredibly potent GPUs to advance AI, yet we also need to be mindful of memory needs, processing speed, energy use, times cost. It's quite complex.
It is! But that's what makes it so thrilling, right? We're perpetually discovering innovative methods to optimize things, enhance model efficiency, and expand the boundaries of possibility. It's a continuous pursuit of improved, quicker, and, well, times larger GPUs.
Well, thank you for clarifying everything, Mark. I definitely possess a much clearer understanding of why these larger GPUs are so essential for AI's future, and I'm confident our listeners do as well.
It was my pleasure, Jenny, and thank you to everyone for listening. We'll return next week with another in-depth exploration into technology.